Well, hello, dearies. We are on to describing quantitative data with numbers, part 2. And I hope that this will not be such a long lesson. We only have a couple of topics to cover. So here we go. One of the measures that we talked about was spread, measuring spread. In last class, we learned that we could measure spread with the IQR, the interquartile range, which we found from subtracting quartile 1 from quartile 3. But there's another measure of spread that we can use, and this is called the standard deviation. So a second way to measure spread or variation is by finding the standard deviation. Now, I include a little comic strip that's actually from your book, and I have to tell you, I look at this and I'm not quite sure what they're saying. The only important thing in this is this equation right here, because that equation is something we're going to come back to with regards to standard deviation. This is actually for population. We'll be only learning sample standard deviation today. Now, variance and standard deviation measure spread by looking at how far the observations are from their mean. And one of the ways that we go about finding, I'm sorry about all that noise, I had to move something, finding the standard deviation is to use a chart. We're going to do this by hand. Later on, we'll be using our calculators, and certainly you are more than welcome to use your calculator to help you. And in fact, next class we'll be learning how to use our calculators to find the standard deviation. But to start off, we want to do this in a methodic, organized way. The more organized you are, the easier this is. Now, this is our basic chart format that we always use, and some of you are taking AP Environmental Science. You should have seen this last week. But basically, this is for our value, our data value, and then this one, we're taking our value minus X bar is the mean, remember. And in this one, we're taking what we found here, what we found in this one, we're squaring it. It's important for us to square things because it allows us to get rid of any negative values that we have. We're going to have some numbers that lie above the mean and some numbers that lie below. If it lies below, then we're going to have a negative number. So it's important for us to get rid of the negatives so we square our values. So here we go. Here are the foot lengths in centimeters for a random sample of 7 14-year-olds from the United Kingdom. We want to do 3 things. We're going to first find the mean because you cannot calculate standard deviation without the mean. Then we are going to find the sum. Remember, that is sum. We learned that last week. We're going to find the sum of the value minus the mean and then the square of that. And we're going to use that in our actual calculation. So this is how we would fill out this chart. We're going to put each value under X. And then we need to find the mean. Now you can find the mean, X bar, this is sample mean, by doing this by hand, just adding those numbers up on your calculator and dividing by 7. Or you can certainly do this by using the calculator. I did it by the calculator by putting a list in and finding the mean, and if I do that, I find out that the mean is 24 centimeters. 24 centimeters. So, in the second column, I'm going to use my value here. I'm going to subtract my mean. So I'm going to write this out, and you'll get the gist. 25 minus 24 equals 1. That is the number. This is the number right here that I'm after. I'm writing this out so you can see how to compute this. So here we go, 22 minus 24. Now notice we have a negative 2. We're in a negative value. 20 minus 24, another negative. 25 minus 24, 1. 24 minus 24, 0. 24 minus 24, 0. And 28 minus 24 is 4. Okay, my computer. Okay, I have no idea what just happened with my computer, so Hopefully this will continue to record. Now I'm going to summate one more time. I'm going to summate all of my numbers from this column here. So if I do that, I end up, I believe, with 0, right? -1, -5, -4, 4, so the sum is 0. This one didn't turn out very nicely. All right, now I'm going to square all of these values that we found here. So I know that 1 squared is 1. -2 squared is 4. -4 squared is 16. 1 squared is 1. 0 squared is 0. 0. And 4 squared is 16. When I sum this, I'll have 32 plus 6 is 38. So the sum of the squared differences is 38. Now again, the reason I need to square this is I need a positive answer. I do not want any negatives. All right, this is the first step. Let's go to the next slide. All right, so now here's a key equation. To find the variation, this is actually the variance. We call this the variance. The average squared distance from the mean, this is our equation. It is this symbol right here just means the standard, S stands for standard deviation, but if it's squared, we know it's the variance of values of x, any numbers. Now notice this part, 1 over n minus 1. We'll actually dive into this in chapter 7. We'll do a whole project on it as to why it's n minus 1 and not just n, the number of data. But let's just suffice it to say right now, it has to do with outliers and making sure we have the best estimate for our true data. Then we notice it's 1 over n minus 1 times the sum of what we found in that last column, that x minus x bar squared. So from our earlier example that we just did about the shoe sizes, we see that the sum here is 38. So our variance, or s squared of x, is equal to 1 over, and we had 7 numbers times 38. So this is 1 over 6 times 38, which should equal 6 1/3. We'll just put 6.33. Now here's the question. What units is that in? Oh, look, I paused so that you could think. Our foot length was in centimeters, but then we squared it. So are we talking squared centimeters? And if we go back and try to use squared centimeters within our graph, our dot plot, or whatever plot that we've used, how can we do that? We can't use two different units, which leads us to how we find the standard deviation. All right, so key equation, standard deviation. When we use the variance to measure spread, we are computing in squared units. However, we cannot have any true meaning unless the units are the same. Therefore, we must take the square root of the variance in order to have a meaningful measurement. Once we take the square root of the variance, we have turned it back into regular centimeters instead of centimeters squared in our example. So from our earlier example, we had that the variance was 6.33. This is the equation for standard deviation. It's exactly the same as the variance, only notice there's no 2 here because it's plain. And we have replaced the 2 with a giant square root sign on the other side. Because we all know basic algebra. If you want to get rid of a squared thing, you just square root both sides. So this is the equation for standard deviation. I'm just going to represent that by SD. So therefore, if this is what we had earlier, the standard deviation of what we just found would be the square root of 6.33. And when we take the square root, we get 2.52 centimeters, because we can go back to centimeters. So what does this mean? It means that the average distance each foot length is from the mean is 2.52 centimeters. We'll do a lot more with this when we're graphing, and we can see, especially in Chapter 2, when we start distributions, we're going to use standard deviations to see how far a piece of data is away from the center. And that becomes really important. So let's see if you can figure out the next question. This is check your understanding. It actually comes from page 64 in your textbook, if you'd like to look in your textbook, although I pretty much said the same thing. All right, first of all, find and interpret the mean of the heights in inches of the 5 starters on a basketball team. All right, well, I know that the mean, x bar, is equal to 67 plus 72 plus 76 plus 76 plus 84. All over 5. And if I find that, if I put that into my calculator or I add it by hand, I find that the average is 75. Now, what does that mean? That means that if all the players were the same height, they'd all be 75 inches. If all the players were the same height, remember, it's that fair share thing, they would be 75 inches. All right, so that's what I mean by interpreting the mean. What does it say? It says everybody's equal, they're all 75. Now we're going to make a table that shows for each value its deviation from the mean and then the squared deviation. Deviation just means how much is it, like not on the mean. If you're going to deviate from a path, that means you're going to turn off the path. So if you're going to deviate from the mean, or the height, which we would consider everything to be equal, how much are you deviating from it? So here we go. Here's our table. Remember, we start off with x. Then we do x I minus x bar. And then we do xi. I put a j, but you get the idea. Minus x bar squared. Somebody's going to get confused. I better change it. xi, just meaning your data, whatever piece of data it is. Okay. I don't know why that's not walking. Okay, so here we go. Here we have 67, we have 72, 76, 76, and 84. Now we know we're going to have some sums here. So I'm going to go ahead and write those down so I know not to forget to summate. Now the average is 75, so 67 minus 75 is negative 8. 72 minus 75 is negative 3. 76 minus 75 is 1. 76 minus 75 again is 1. And 84 minus 75 is 9. Now when I add these all up, I end up with 0. Now let's square them. I'm going to square negative 8 squared is 64. Negative 3 squared is 9. 1 squared is 1. We have another 1, and then we have 9 squared at 81. Now when we add all of these up, we get a sum of 156. So now, the deviation from the mean, we've shown each one has been shown by our calculation here. So in other words, 67 deviates from the mean by negative 8 points. It's 8 points below. Does that make sense? Hopefully. All right, so show how to calculate the variance and standard deviation from the values in your table. Well, first of all, let's remember that the sum of xi minus x bar squared was equal to 156. All right, so we know that we have 5 values. So the variance is equal to 1 over 5 minus 1 times 156, which is 156 over 4, which is 39 inches squared. But again, we know we can't use that, so we're going to change it to the standard deviation by taking the square root of the variance. which is the same thing as taking the square root of 39 square inches. So what do we get? We get 6.24 inches. Now we're back into our normal units. So the standard deviation, the average distance each number is from the mean, is 6.24 inches. So how can we interpret this? The players' heights vary about 6.24 inches from the mean height of 75 inches on average. And we have just completed another standard deviation problem. Standard deviation is not difficult. Don't ever think that it is. All it is time consuming, especially if you have very many pieces of data. You can all do it easily. All right, so let's choose a measure of spread. Well, basically, here's what you need to know. If something's skewed, you just don't want to go with the mean or anything that has to do with the mean. And since the standard deviation is tied to the mean, we probably don't want to use it. So we're going to use the opposite. So both the median and the IQR are usually better than the mean and standard deviation for describing a skewed distribution, or a distribution if you have strong outliers. Therefore, we want to use the mean and standard deviation only when we have reasonably symmetric distributions with no outliers. And we'll be looking at a lot of distributions next chapter. But remember, when you don't know what to use, the best first thing to do is to draw a graph. Box plot, number plot, stem and leaf. Stem and leaves are great. They're like my favorites because they're really quick and easy. And by the way, that was my dog barking and going out the doggy door. So if you hear a lot of that, that's what that is. Okay, so here we go. Who texts more, male or females? This is an example from your book on page 67. And I actually meant to put the graph in there, but I forgot to, apparently. So does the data give convincing evidence that females text more than males? Well, the best thing to do is to start off by getting yourself a 5-number summary for both things. So 5-number summary. I want to know the mean. I want to know, we can do standard deviation too. S of x. We're going to do the min, quartile 1, the median, quartile 3, the max, and the IQR. Now, because we are using video, I am not going to work each of these out because by now you should have an understanding of how to find the mean, standard deviation, and the rest of it. So I'm just going to put the answers down for you. If you can't follow me, you can look in your book. So for males, whoops, wrong thing. For males, we have, let's just draw this line here. Let's see, males. The average number of texts is 62.4. The standard deviation is 71.4. The minimum is 0. Quartile 1 is 6. We have 28. Then 83, 214, and an IQR of 77. For females, okay, I may have to lock my dog up because I'm going to just go crazy. 128.3, 116, that's a huge deviation. 0, 34, 107, 191, 379, and 157. All right, if we go ahead and put these out on a box plot, we should be able to get a good idea of where the data is lying and if it's skewed or not. Okay, so if we look in our book, we would see that if we do a box plot side by side, or actually above and below, we're going to do males up here females down here. And then we're going to put the scale down here, 0, and they're in hundreds. 100, I think. 200, 300, 400. And again, I'm estimating. Now, if we do our IQR, we'll find some outliers in the male data. I'm just going to tell you, for time's sake, that outliers for men are 273 and 274. I don't have that. 213, I can't read. 213 and 214 are the only outliers that we have. There's no outliers for the female data. All right, so let's see what we end up looking like. The males have a minimum of 0, and we know that the median is 28, so it's pretty far down here, with a quartile 1 of 6 and a quartile 3 of 83. And again, this is just a really quick graph, and a max of 214, which is way off the scale. The acceptable value that's below that 213 is 127. So that's our other whisker. And then we'll have the 213 outliers here. Now the females are going to have 0 text. But then notice we have a median of 107. We have quartile 3 at 191. Quartile 1 at like 30. And then we have a max of 379, which actually is not an outlier because this data, the mean is very big here. All right, it is completely evident by looking at this that females text more. This is even a dumb question because you can look at the data and see that. But in addition to that, this data is really skewed. You can see that the female is extremely skewed. So if you look at data, especially in a box plot, and you see extreme skewness, do not choose to use the standard deviation in the mean. Choose the IQR and the median. That's the best representative of the data. So in this case, what's the data? Well, females have a median of 107 texts, and males had a median of 28. Now, it would be interesting to know when this data was gathered, because my guess is that today the data would be a little different. So when we're choosing which type of spread to use, IQR or standard deviation, always graph your data first. It gives you so much more information. This is the end of Chapter 1. We've completed all of our work. Our test will be next week. I have pushed it off a bit so that we can further explore these concepts in class. Make sure to come prepared in class for any questions you have. In addition, for extra information, watch the video at the following link. If you need help. If you don't need help and you're feeling good about it, don't worry about it. But if you go to this website, it's kind of interesting. It talks about standard deviation and really gives you a practical application. Learner.org. We'll be using some more of these videos, but we just aren't going to get to it in class. Courses. Against all odds. Backslash unit pages, backslash unit 6. And I will also put, there goes Buddy. I will also put this web link on the portal. Have a great night, guys.